So my name's Keegan. I'm a senior software engineer that works in the security organization at Indeed. First, I'll tell you a little bit about Indeed. I'm sure you've all heard the name. It's the most visited job site in the world with over 300 million unique visitors every month and hosting over 245 million resumes. We always say that our mission is to help people get jobs. There we go. Slides weren't moving. Within the security organization, we like to say that our job is to help people get jobs securely. And we have several initiatives every year to enhance Indeed's security posture. Zero trust is one of the things that was kind of foundational for what we want to do with identity and security going forward within the company. And this is a quote from Ken Adler, who's a tech fellow at Indeed, kind of describing why we were looking at SPIFFE SPIRE and why we chose that as the foundation for our zero trust architecture that we're building. And in addition to it providing a good foundation for us, SPIFFE, because it's a graduated CNCF project, it positions itself well to be one that will gain adoption and widespread industry support for future integration needs beyond our initial use cases that we have for it. And SPIFFE gives us a tool set for uniform identities that we didn't really see in any other solution that we kind of looked at for this. So the first use case that we had was one that Dimitri mentioned already, where we were using SPIFFE within our service mesh. This was a good first use case for us to kind of prove that this will work for us, given that it has native support for SDS, which Envoy uses, which was the underlying technology of our in-house service mesh technology at the time. We're now moving to Istio, but that's also still built on Envoy, so good integration with that. We used to have, excuse me, we used to have an existing process that used the Kubernetes certificate manager process, which had really long-lived certificates. So this was kind of allowed us to slide into our existing infrastructure without making a lot of dramatic changes to our setup. And this was something that the service mesh team had already asked the security department to evaluate and implement on their roadmap. So this is our current architecture now that this is deployed. You have your pod that's running your workload on it, and then there's a sidecar there for Envoy, that's the Envoy proxy for everything that's communicating on the service mesh. And then it's secured using MTLS between different pods on the service mesh and using SDS to communicate to the agent to retrieve the cryptographic material. This should look pretty familiar to anyone who's familiar with Envoy or Istio. Sure there's nothing else I missed here. All of this is pretty industry standard. We didn't deviate from what you'll see in the SPIRE docs for how to implement this. So the outcome of this is we've got over 4,000 workloads already using this on the service mesh. We went from a single certificate that lasted 6 to 8 months that was kind of manually rotated to workload specific instead of shared certificates that last 48 hours. And that was a TTL we chose, and that's tweakable, obviously. And we've been live for about a year now. It was fall of 2022, I think, when we threw the switch on this. Or no, 2023. Is that right? No, 2022. Get my years mixed up with the new year. And haven't really had a lot of issues for this use case. So this was a pretty conventional use case. Our next use case is kind of where things got kind of more interesting for us, where we can have a deeper integration with SPIRE. So in parallel, while we were building that service mesh use case, we had another use case where we wanted to use OAuth for workloads to be able to authenticate themselves to different services, such as AWS SQS queues or Confluent Cloud topics or anything that could support OAuth as a potential target for us to simplify the workload access. The way we did this for now, since SPIRE wasn't deployed, since we're building this in parallel with that is that we were mounting Kubernetes secrets and using a third-party IDP that's going to be the issuer of the JOTs, and then registering this IDP with the different services that we support on this platform for them to validate that token. I'm checking my notes here to make sure I've covered everything on this slide. There's also an admission webhook that we have here, which does things like mount the secret and set environment variables in the workload, such as the AWS Web Identity Token file, so that the workload is able to use its native authentication mechanisms to tie into that. This next slide here is what we're trying to replace the previous slide with, and this is what my team is working on right now. So instead of the custom or third-party IDP, we'll replace that with these SPIRE components. We're introducing a new component here, the SPIFFE helper, which will interact with the workload API of the SPIRE agent to retrieve the JOTs for the workload. But you can see overall, this reduces the number of custom components that we have to maintain. This is kind of more standardized and allows us to eliminate that third-party IDP, which we're licensing. So I want to go over some kind of pros and cons of using SPIRE as this solution versus the solution that we had before, our custom solution. It does make it, we have a lot fewer parts, like I mentioned, and a lower maintenance cost, and eliminating that licensing component. Builds on SPIRE. We wanted to have SPIRE as the foundation for our zero trust architecture at Indeed. We can combine things that a workload is using to authenticate to into a single identity. So we can have a single set of cryptographic materials instead of like, here's, a cert that we're using for this database access, and then another token that we're using for this other access, and then having the developers have to put all of that into Vault and manage all of that. We've got a single managed identity for each of our workloads. And it makes it less likely that you can accidentally grab the wrong secret. Like if you have secrets that are shared in a namespace, I'll go back a couple slides here. On the current one, where we're storing this into the Kubernetes secrets, if you have two workloads deployed in the same namespace, you could accidentally grab the wrong one, since that's the granularity of Kubernetes RBAC. Some of the downsides are we were able to kind of reach in, or could at least in theory reach in, by setting the appropriate Kubernetes RBAC to access those secrets and help the customer troubleshoot by kind of reaching into their namespace, where now it's isolated only to that workload. Nothing else can kind of reach in and get that, which makes it a little harder to troubleshoot, but also more secure. So that's kind of the trade-off there. There's also a use case, which I put this bullet on, and I guess this has now been delayed as something that we have as a requirement within the company after I prepared the slide, where there were people that were wanting to impersonate QA workloads on their local dev machine for integration testing. That's something we haven't solved yet, but something that we now don't have an immediate need to solve. And then, of course, anytime you add a sidecar into your pods, there's an additional compute cost associated with that, since you have another running process that's there. This last one was just to note a final thing we'll do after we're done with this initial effort here, is to eliminate that mounter here, which is the webhook, which is a validating or a mutating, admission webhook, for the reason that mutating admission webhooks have a lot of kind of downsides to them, in that, like, if they go down, then it obviously blocks any pods from being able to be spun up on the Kubernetes cluster. And the Kubernetes clusters, the way we use them at Indeed, are shared resources. So they're not team specific or group specific clusters. We have a standard Helm chart, which we use to deploy most of the stuff at Indeed. So it made more sense just to tie into the Helm templating that we had and eliminate the rest associated with that admission webhook. And I think that's everything I had. Were there any questions on this?
I know we had a few questions from Eli, and he did say he did get one answer. Eli, do you want to ask?
Yeah, sorry, I'm just like writing questions so I do not forget about them. Some get answered along the way. The cert man, I had a question related to cert manager. Like, do you use it for ingress mostly, or like what's a use case there that Spire can solve for you?
So that was what we were using for our service mesh communication. So it was terminating TLS connections within the mesh. It was the upstream authority for the certificates minted by our like custom service mesh architecture. Does that make sense?
So it's like a previous service mesh architecture that's been used like long-lived credentials. I didn't kind of catch that.
Actually, I guess I don't have a detailed picture of that. So instead of using Istio, we had a custom service mesh architecture that we're currently in the process of replacing with Istio, but it's still built on Envoy. And the root of the authority for the certificates that are used to terminate those connections within this custom service mesh
I
was
see.
A cert manager.
Gotcha. So it's like a custom control plane that just managing an envoy, like something you built in-house.
Yeah.
Gotcha. Yeah, we had something similar. Got it. Thank you. Do you use sorry, one more question related to this. Do you use ingress controllers or anything like this? Or planning to use maybe?
They do, I think, for stuff that's coming from like outside of the cluster, between clusters. But honestly, I'm not on the service mesh team, and I'm not exactly sure the details of that.
Gotcha. Yeah, I was wondering if you use like the same kind of certificates for ingress across clusters, or it's like a different story.
I think they did, because I remember looking at the contents of that certificate, and I think they were the same between all the clusters, even though there was a separate cert manager, I think, deployed for each.
Gotcha. All right, thanks.
Correctly. Yeah. As a shared route.
Great. I think there was a question around SPIFFE helper, so Victor got the link for that. Any other questions?
Yeah, I forgot to mention that was something that was already available to us. There's one more here.
Yeah,
oh, that's a note, not a question. The other thing I'll mention, I guess, as my team's continuing to work through this, was some of the challenges that we're currently working through, just really briefly. The two that we've kind of run into were that some of the vendors that we were looking to integrate with have a limit to the number of keys that they can support on that JOX endpoint. For example, AWS was, I think, 100. Confluent Cloud had a lower limit, and we were working with them to increase that limit, at least on our account. So that's something that you may want to keep in mind depending on the size of your Spire cluster, because there's going to be one per server instance, and then depending on how often they're rolled over and whatnot, that can kind of balloon the size that are in your key set. And TTLs are one of the things that my team, I think, very recently in the last week, I'm on parental leave, but I've been watching kind of what they've been up to. Adjusting the TTLs to avoid rolling the keys over unnecessarily and ballooning that key set size is important too.
Yeah, I think I forgot to mention like a big thank you for not only presenting, but also presenting because you're out on a paternity leave and you took time out to present to us. So thank you for that.